Hi, I'm Hussein Mansour. This paper titled Towards New Design Patterns for Museum Exhibition Halls Using Integrated Algorithmic Generative Techniques, presented by Hussein Mansour, Sherif, Sheta, and Medhat Samra. This paper aims to define the concepts, methods, and techniques needed to establish a multifaceted yet comprehensive description of complex problems facing conventional architectural design and how to decode the problems through integration between techniques and technologies in generative algorithmic and its impact of the quality of design solution. To attain these aims, the study explores the ability of integrated algorithmic techniques in dealing with complicated problems in the design of museum exhibition halls. So the research problem is how such methodology can implement the integration between generative design techniques. In this diagram, we tried to decode each system to its main elements. The literature review focused on technical aspects of each generative design technique and confined to their application to architectural design. The aspects are system, introducing main ideas and concepts, components discussing how each system may be structured, the units showing the unit types that a system can recognize and deal with, control space commenting on some properties of each system, the grammars showing how each system works, its behaviors or rules, representation discussing how each system or how each design component and units are represented, techniques based how new techniques emerge from founder. Algorithmic systems may run in a parallel and or sequential and or random fashion. Parallel algorithms deal with elements simultaneously and separately without affecting each other. Sequential algorithms deal with elements one by one, such that a predecessor affects its successor. Random algorithms do not follow any specific order. These diagrams show the location of techniques in the algorithmic space by classifying systems. In this diagram, serial-to-tile system shape grammar are generally represented in graphical forms that result from transformations and operations like addition, rotation, subtraction, etc. in the initial elements, whereas the patterns from swarm intelligence generally result from the autonomy of the agents or by plotting the agent's activities. This figure paves the way for the methodology of integration between various techniques. The integration methodology applied on museum exhibition halls to expand design exploration and create new design patterns through experiment proposals. First of all, exhibits position. Exhibits positions are cells that have characteristics, sizes, and spaces that their places change and evolve over time to meet the requirements of the display. Serial automata is a collection of cells on a grid that evolve over time according to a set of rules driven by the state of neighborhood cells. Live cells present the exhibits and dead cells present users' paths. In a structured system, according to the result from exhibit position stage, the positions have been identified. These places are inputs in the stage of the structure system, and due to the complexity of the structure system methodology, swarm intelligence and L system are used to create experimental solutions for the methodology and not as a final product. The void forming after this step are the internal interactive spaces are based on the positions of the exhibits and structure system. The main lines of these spaces are inputs for the next stages. The global is to generate design language of these lines and shapes. Shape grammar technique used as a design tool with swarm intelligence to understand the rules that can be applied. Here in user behavior cannot be controlled, but rather can be tamed and make it interactive. with all the previous inputs like exhibits, position, structure system, and internal interactive spaces. And finally, the form generation inputs are void lines, subtraction, structure lines, addition, and so on behavior lines. So automata will simulate in 3D on exhibits position live cells. The output generates the form using swarm intelligence and optimization process to determine the best void and form that achieving the methodology. From the previous discussions, any generative system to be applicable to a certain problem, it needed to be customized to provide more specific and less generic. The downside to this being that the more it is tailored to a specific context, the less useful it may be for others, so it is not possible to obtain an integrated architectural design resulting from a single generative system. Therefore, the paper explores and discusses the extent to which integration between these systems can be applied. The paper proposes a methodology of unintegrated generative systems and discusses the challenges and requirements for developing methodology. The designer viewed as a tool builder or tool developer and central to the design development through an open source system. This interactive expert system can be formed by the designer according to different case studies. He or she can interact and modify inputs, evaluation criteria, technique selection, building type, plugins used, and optimization criteria. Transforming outputs technique into another inputs technique is the core of this methodology. The methodology has been experimented on hypothetical museum exhibition hall to test the feasibility of an integration and identify the conceptual and technical requirements. Thank you.